Hello, my name is Craig Lastrado, and today I'm going to be talking about IoT security and trust. For the overview, we first have an introduction where I'll explain a bit about what IoT is and where it started from. Then I want to explain about IoT architecture, and then the security architecture, and finally security measures, which will help in security and privacy of IoT devices, and finally the conclusion. Internet of Things is an upcoming technology. As the name suggests, it is the connectivity of everyday devices with each other. Nowadays, many devices are embedded with various sensors. This enables IoT to work, and the main function of IoT is to enable these devices to interact with each other. For example, when your alarm goes off in the morning, these sensors will send a signal to your toaster and coffee maker to start doing their jobs, and all this happens without any human intervention. This term was first coined in 1998 and is defined as the Internet of Things allows people and things to be connected anytime, any place, with anything and anyone, ideally using any path network and any service. The ultimate objective of IoT is to create a better world for human beings in which objects around us know what we like, what we want, and what we need, and hence accordingly act without explicit instructions. Based on the application domain, IoT applications can be classified into five categories. They are smart medical devices, smart home, smart city, smart environment, and smart enterprise. Now we do have smart medical services, smart homes, and smart environment, not so much smart cities and smart enterprises. There has been a tremendous increase in number of smart devices over the past decades. Um, examples could be mobile phones and various other things. The problem with this is that the number of potential threats has increased because of these smart devices, and security and privacy and trust are one of the challenges that the designers and programmers face in creating these smart devices. Now we have the IoT architecture. The architecture consists of a series of layers. Architecture in this context is defined as a structure for the specification of a network's physical components and their functional organization and configuration. Its operational principles and procedures, as well as data formats used in its operation. This IoT architecture is from the paper of Shahid, Banadella, and Aziz from 2017. This is the basic um, figure that from the paper. Um, it basically shows what some of the functions of each layer are. We'll go into more detail in the next slide. In the perception layer, it's a layer similar to the one from the OSI model, and it consists of different types of sensors like the RFID, ZigBee, QR code, etc., and various environmental elements. Then we have the network layer. It's called network layer, and it gets data from the perception layer, just like how it is in the OSI model. It collects data from the lower layers and links it with the internet from the network. Third is the middleware layer. This has two essential functions, which is service management and stores the low layer information in the database. Then is the application layer, which is the fourth layer. It receives information from the previous layer and gives a more general management of the applications presenting its information. This totally depends on the type of devices and their purpose of the perception layer. Last is the business layer. This layer covers the entire functions of the IoT applications and service management. It can be used to create graphs, business models, flowchart, executive reports based on the data received from the low layers and the effective data analysis process. Now the IoT security architecture. This is the diagram from the IoT security architecture. It explains the basic functions and uses of each layer. In this architecture, we have three layers as compared to the previous architecture. This is mainly from security point of view. The three layers are perception, network, and application. Each of these layers has various security problems, which we'll go into more detail. So in the perception layer, the gateway node is a sensitive element. It can be easily controlled by attackers if they make an effort. Um, it can leak all information, including the group communication key, the corresponding key, radio key, etc. And this can threaten the entire security of the entire network. In the network layer, the general security problem of the communications can threaten the confidentiality and integrity of the data. The application layer has different applications for different users. Each application will have a large number of users. In order to prevent illegal user intervention, one should use effective authentication technology. Spam and an identification and processing of various malicious information can also be considered. So the security measures that can be used to help secure IoT devices, um, first can be encryption. The main function of encryption is to prevent data tampering and to maintain confidentiality and data integrity. This can be achieved in two ways, either node to node, which is a hop to hop, or you can use end-to-end encryption. Node to node encryption is processed in network layer. It provides ciphertext conversion on each node to make it more secure for network layer. End-to-end encryption is executed on the application layer. Right now, quite a few applications right now use end-to-end encryption, like for example, WhatsApp, which has recently started using end-to-end encryption, as well as Facebook. Confidentiality is second security measure. This basically means the data should only be accessible to authorized users. These users can be either human, other IoT devices, or external devices, because these devices need to communicate with each other. So, not this, and the purpose of IoT is mainly is that there shouldn't be any human intervention for it to function. So, IoT devices also should be allowed to be authenticated. It's important to ensure that the sensors in a particular node don't allow the collected data to be accessed by neighboring nodes. So just because the nodes are side by side, it should not be allowed complete access without proper authentication. Sensitive information should not be leaked to any unauthorized reader using a RFID electronic tag. Third is authentication. Authentication is important at each IoT layer. At the perception layer, the sensor nodes must authenticate themselves initially to prevent DDoS attacks. The standardized framework for authentication purposes is OpenSID. It allows the user to be redirected somewhere else and come back with verifiable assertion. Fourth is authorization. This controls a device's access throughout network. The relationship between authentication and authorization is used to exchange appropriate information. Open authentication is a framework used right now. Fifth is certification and access control. Certification is a method for confirming the true identity of both entities that are communicating with each other. PKI, which is public key infrastructure, is right now used. For conclusion, researchers have proposed many solutions to help secure IoT devices. They have proposed stronger encryption and more authentication of every layer. Internet of Things, it's happening right now, and there's a need to address its challenges and maximize the benefits while reducing its risk. It's a very interesting technology and definitely should be more focused on. Thank you. My references.